Hello. In the previous video, I showed you some basic kinds or logical forms of some basic logical valid arguments, as well as a couple of fallacies, invalid arguments. So in this video, let's just look at some more examples. Most, but not all of these, will follow the forms that I talked about in the last video. So see if you can decide for each argument I present, is it one of these particular patterns, and if so, which one? And is it valid or invalid? Here we go. Example number 1. If you're human, then you make mistakes sometimes. Steve is human, therefore, Steve makes mistakes sometimes. Valid or invalid? Well, let's translate this into symbols first of all. If P, then Q. P standing for you're human, Q standing for making mistakes sometimes. Steve is human, so the P part is true. Therefore, Steve makes mistakes sometimes. Therefore, the Q part is also true about Steve. Well, that is direct reasoning or modus ponens, and it is valid. How about this one? If you really loved me, you'd give me flowers on Valentine's Day. You didn't give me flowers on Valentine's Day. Therefore, you don't really love me. In symbols, this would be if P, then Q, not Q, therefore, not P. Do you recognize this pattern? This is indirect reasoning or modus tollens, or reasoning by contrapositive, and it is valid. So if you agree with the premises, you have to agree with the conclusion. If the premises are true, and I'm not saying they are, but if they are, the conclusion must also be true. Next example, if I get my paycheck today, I will have money. If I have money, I will take you out to dinner. Therefore, if I get my paycheck today, I will take you out to dinner. So in symbols, this would look like if P, then Q. So the P stands for getting the paycheck, the Q stands for having money. If Q, then R. Q stands for having money, R stands for taking you out to dinner. Therefore, if P, then R. This is, do you recognize the pattern? Reasoning by transitivity, and it is valid. Next example, if your battery is dead, your car won't start. Your car won't start. Therefore, your battery is dead. In symbols, if P, then Q. Q, therefore P. Do you recognize this? This is the fallacy of the converse. And of course, being a fallacy means that it is invalid. It's true that if your battery is dead, your car won't start. And it's true that your car won't start. But just from that, you don't know that your battery is dead. It might be, but there might be some other reasons why the car doesn't start. So you can't conclude the conclusion just from knowing the premises. Let's try this one. If this movie has car chases in it, Tom will like it. This movie does not have car chases in it. Therefore, Tom will not like it. So in symbols, if P, then Q. Not P. Remember, P stands for the movie has car chases in it. So the second premise is the negation of that. The movie does not have car chases in it. And the conclusion, therefore, not Q. Do you recognize this pattern? This is the fallacy of the inverse. Just because a conditional is true doesn't mean the inverse of that conditional is true. So this is invalid. How about this one? If you are a doctor, then you have a stethoscope. If you are a doctor, then you can prescribe drugs. Therefore, if you have a stethoscope, then you can prescribe drugs. Let's look at this in symbols. If P, then Q. I'm using P to stand for you are a doctor, and I'm using Q to stand for you have a stethoscope. If you are a doctor, then you can prescribe drugs. Remember, we're using P to stand for you are a doctor, so this would be if P, then R. Therefore, if you have a stethoscope, you can prescribe drugs. If Q, then R. And at first, this looks like reasoning by transitivity. But is it really? No, not really. That would be if P, then Q, if Q, then R, therefore if P, then R. But this is not that pattern. It's mixed around differently. So this is not reasoning by transitivity. If you want to look at a truth table, here's what it looks like. If we make a truth table of this argument, and you see there's a false in this last column, that means this is not a valid argument. There is a way that all the premises could be true, but the conclusion could be false. That happens when P is false, that is, you're not a doctor. Q is true, that is, you do have a stethoscope. And R is false, that is, you can't prescribe drugs. Then it would be true that if you are a doctor, you have a stethoscope. That doesn't mean only doctors have stethoscopes. It's true that if you are a doctor, then you can prescribe drugs, but it's not true that if you have a stethoscope, then you can prescribe drugs. So, this is an invalid argument. How about this one? All politicians like to talk. The mayor is a politician. Therefore, the mayor likes to talk. So what's going on here? Well, an all statement could be rephrased as an if-then statement. If somebody is a politician, then they like to talk. So we can symbolize that as if P, then Q. P stands for being a politician. Q stands for liking to talk. The mayor is a politician, so P is in fact true about the mayor. Therefore, the mayor likes to talk. Therefore, Q. So do you recognize this pattern? If P, then Q. P, therefore Q. That is direct reasoning or modus ponens, and it is valid. Okay, how about this one? Either Tony ate my steak or the dog ate it. Tony did not eat my steak. Therefore, the dog ate it. So, either Tony ate my steak or the dog ate it. That's a disjunction, an or statement. P or Q. Tony did not eat my steak. I had P standing for Tony ate my steak, so we have the negation of that, not P. Therefore, the dog ate it. Therefore, Q. Do you recognize this pattern? This is a disjunctive syllogism. We know that either P or Q has to be true. We rule out P. We know that P is not true, so Q must be true. If Q were also false, then we wouldn't be able to say that P or Q was true. So this is valid. How about this one? If you use Bleem toothpaste, you will have whiter teeth. If you have whiter teeth, you will be more attractive. Therefore, if you use Bleem toothpaste, you will be more attractive. If P, then Q. If Q, then R. Therefore, if P, then R. What do you think? Is that valid? Yes, that is a legitimate reasoning by transitivity, and it is valid. So, if you believe the premises, if those two premises are both true, then the conclusion must also be true. How about this one? If a fruit is blue, it must be a grube. All grubes are poisonous. Therefore, if a fruit is blue, it is poisonous. Remember, this comes from that example that I started things out with way back at the beginning of this series of videos on logic. So, you're on that alien planet. You know that if a fruit is blue on that planet, it must be a grube. You know that all grubes are poisonous. Is that enough so that you know for sure that if a fruit is blue, it is poisonous? Well, in symbols, if P, then Q. If blue, then grube. All grubes are poisonous. So if a grube, then poisonous. If Q, then R. Therefore, if a fruit is blue, it is poisonous. If P, then R. What does that look like? Reasoning by transitivity, which is valid. Okay, what about this one? If a fruit is a fizz, then it is yellow. All fizzes are safe to eat. Therefore, if a fruit is yellow, it is safe to eat. In symbols, if fizz, then yellow. If P, then Q. If fizz, then safe to eat. If P, then R. Therefore, if yellow, then safe to eat. If Q, then R. So what about this? Well, this is a pattern you've seen before earlier in this video in the example about the stethoscope and being a doctor and being able to prescribe drugs. It's that same pattern, and just like back then, this is not reasoning by transitivity, and it is an invalid argument. It's possible for the premises to be true, but for the conclusion to be false. And that happens when P is false, that is, the fruit is not a fizz. Q is true, that is, the fruit is yellow. And R is false, that is, it's not safe to eat. So you might have a fruit that's not a fizz, is yellow, but is not safe to eat. And one last example. If you don't study, you won't pass the final exam. If you don't pass the final exam, you won't pass the course. If you don't pass the course, you won't graduate. Therefore, if you don't study, you won't graduate. This is a little different because it has 3 premises before the conclusion. So do those 3 premises together, premise 1 and premise 2 and premise 3, logically imply that the conclusion must be true. Well, let's look at it in symbols. If P, then Q. If Q, then R. If R, then S. I had to use a new symbol, S. Therefore, if P, then S. Well, this is valid reasoning by transitivity, just with kind of one extra step, but P implies Q, which implies R, which implies S. So by that chain of reasoning, P implies S. If you know P is true, then you can deduce that S must be true. So that is valid. So I hope you enjoyed this series of videos on logic. If you have any questions or comments or other things you want me to address in upcoming videos, let me know. Leave a comment, send me an email. Hope this was helpful or interesting or enjoyable. Thanks for watching.